Hi guys, happy to see you all back through this video. So in this video we're just going to focus on the anatomy of cloud infrastructures. So under the anatomy of cloud infrastructures we are having three subtopics, and the first subtopic only we are going to see in this video. Okay, so let us see one by one. Okay, and as you all know, what do you mean by anatomy? In the sense we study of internal working. Okay, how how the cloud infrastructures internal working has been carried over, and that's the thing those things only we are going to study under this topic. Okay, and in this video just going to focus on the first internal process, that is the distributor management of virtual machines. Okay, so let us see one by one. And coming to that anatomy of cloud infrastructure, first we are going to see about the five main characteristics of the commercial IaaS cloud providers. In the sense, obviously it is on demand. Okay, and on demand in the sense whenever the user is requesting, and during that time only the service is going to be delivered to the cloud user. Obviously it has to use the virtualization technology to deliver the services, and it also has a simple remote interfaces to manage those set of resources that are being provided to the cloud user. And obviously it is a pay as you go cost model. And so this set of cloud infrastructure, this set of IaaS cloud infrastructures, it has to operate large data centers. Okay, and these are some of the main characteristics of the commercial IaaS cloud providers. Okay, and coming to the main core, core of the particular topic, core content of the particular topic, VI management, virtual infrastructure management. Okay, and why do we need to manage such kind of virtual infrastructure? In the sense, say for an example, when you wish to create a simple virtual machine, what are the process that involves? In the sense, we need to the fair amount of configuration would be there, and we need to prepare the VM software environment, as well as we need to configure the network for the particular virtual machine. And these three set of processes have to be carried over for creating a single virtual machine. And and this set of process will be carried out, will be done on the fly, which means that on the fly, which means that the time taken between the VM requested and it is being available to the user is very less. Okay, that is called as on the fly. On the fly, and all this process will be completed, and will be that services will be provided to that end user. Okay, and as a virtual infrastructure manager, what he has to do in this sense, he has to allocate the resources efficiently, and also he has to react to the changes, according to the physical infrastructure and according to the particular environmental infrastructure, according to the resources that are available in the particular environment. Okay, and he has to take care here as a virtual infrastructure manager, he has to take care of each and everything. Okay, and all this process will be done automatically by the tool. That's the thing only we are going to study under this topic. And in a private cloud infrastructure, what are the main problem in a private cloud infrastructure is, in a private cloud environment, all the resources will be collected in a pool, isn't it? And this set of resources, whatever the resources that are reside in the resource pool, that is finite. Okay, that is finite number of resources only will be available in a private cloud environment, Okay, and in that scenario, what are the main problem? What are the main problem that they would face? In the sense, suppose if the particular cloud environment is facing facing humongous number of requests, more than they anticipated. In the sense, then obviously those set of requests, once the threshold level has reached, and those set of requests will be put up in a queue. Or the particular requests will be discarded. Okay, and so those set of problems will be arise in a private cloud and virtual infrastructure. And how this problem can be done? How this problem can be easily reduced? With the help of one of the main tool that is called as OpenWRT. That is the thing only we are going to see under this topic. And so that can be easily done with the help of distributor management of virtual machine. And whatever the problem that we have seen what are the problem that we have discussed just before, and those problems can be easily reduced with the help of this distributor management of virtual machine. Okay, so let us see this. As we earlier said, the main problem is that we need to properly manage the resources that are present in the particular environment. Mainly when we are going into the high performance computing, we need to properly manage the resources, And when we are setting up the virtual machine, we need to customize the software requirements, as well as we need to setting up and manage the particular network, and in order to overload the in order to reduce the overhead of the virtual machine. Okay, and how this can be easily done in the sense, and before that, in a virtualized infrastructure, one of the main thing where we need to focus on this, we need to select and schedule the computational resources. And the state of the art in VM based resource scheduling algorithm is, they follow the static approach. Okay, and under which they have used the greedy allocation strategy. As you all know, as you are aware about the greedy algorithm, right? In an optimal cost, all the resources will be utilized properly. In an optimal cost, all the resources will be utilized properly. Okay, in such a way, they will allocate the resources to the end users. Okay, and how this can be easily done with the help of the Open Nebula, and all these things can be easily done with the help of the Open Nebula Virtual Infrastructure Engine. It is a tool by which we can easily manage all sort of things. We can do all sort of activities. Okay, and Open Nebula is capable of managing group of interconnected VMs with the support for the Xen and KVM and VMware platform. Okay, and it can also be used to build hybrid clouds by interfacing with the remote cloud sites. Okay, and in a previous video we have discussed about the Xen, right? And these things are type 1 hypervisor. These things are type 1 hypervisor. Normally these type 1 hypervisor are deployed over the underlying hardware. And along with the type 1 hypervisor, the Open Nebula works. Okay, in order to manage the virtual machine, in order to manage the virtualized infrastructure that are reside in that particular cloud environment. Either it could be a private cloud environment. Okay, got it. Okay, and coming to that, life cycle of the VM, and before that, this particular Open Nebula, the VM is, when we are having the VM, it has the following attributes. It might have, a memory and CPU. Obviously, the particular VM must have a network interface card, obviously, in order to interact with the user. And also it has disk images, disk images which actually comprises of the data that the particular VM is going to deal with. Okay, and also the recovery file. Okay, suppose if the VM is disrupted, then with the help of recovery file we can recover the lost data. Okay, and these set of attributes also we have to consider when you are creating a virtual machine under virtualized environments. Okay, and in a Open Nebula there is some sort of life cycle will be followed. One is resource selection and another one is resource preparation. And and the remaining thing is VM creation and VM migration and VM termination. Okay, so let us see one by one. Okay, and coming to the resource selection, and once the user has requested for creating a virtualized machine, okay, and for the particular virtual machine, the resources has to be selected from the resource pool. And how the resources will be selected from the resource pool in the sense based on the rank scheduling policy. Okay, say for an example, if I am having if the user is requested for 1 GB of RAM, and even the 1 GB of RAM, even though it has n number of 1 GB of RAM, okay, and based on the ranking, particular the RAM is having, and the high prioritized resource will be allocated. Okay, and based on the ranking policy, the resources will be selected from the resource pool. Once the resource has been selected, then the resources will be about to prepare. Which means that the disk image of the VM will be transferred, transferred to the target physical resources, and during the booting process, and everything will be set up. The particular VM will be contextualized, which means that setting up the network, and to create a host name, and also to register the particular VM with the services, and everything will be prepared over here. Prepared over here before handing over the virtual machine to the end user. all the process will be carried over, and the disk image will be deployed in the virtual machine, and the network will be set up, and the particular virtual machine will be registered as a new services. Everything will be set up before that will be handed over to the end user. Okay. Once once the resource has been prepared, then the particular hypervisor will create that way, the particular hypervisor will boot the particular virtual machine. Okay, and once the virtual machine can be created, once the virtual machine is running, then obviously there is two possible states that we could arrive. One is the VM migration, and another is the VM termination. So when the VM termination occurs in the sense, when the VM is about to shut down, then the VM termination will take care. Okay, suppose, say for an example, as we have seen in the earlier video, when the VM is in powered up, when the VM is in on state, suppose if I am migrating that particular VM from one host to the another host, then the VM migration will come into picture. And about the VM termination, so when the VM is about to terminate, and as a hypervisor, the hypervisor, what it has to do in the sense, along with the OpenNebula, what it has to do in the sense, it has to take the image, it has to take the disk image. Okay, it has to take the disk image about the disk image of the particular VM, and that has to be transferred to the known location. And this particular disk image, which consists of whatever the updates, whatever the process that has been done, whatever the updates or whatever the file or whatever the folder that has been created under this particular virtual machine, and everything will be properly taken as an image, and that will be put up in a known location. Whatever the changes that has been made in the VM, and that will be taken as a disk image, and that will be put up in a known location. Okay, and why do we need to have such kind of backup in this? Why do we need to take an image of virtual machine in the sense? Because say for an example, in July 10th, I have created on virtual machine, I have worked. Okay, and about 12 p.m. I have terminated the particular virtual machine. Again, I coming on the next day, July 11. If I am starting the machine again at around 10 a.m. in the sense, then from the last moment, from the last checkpoint, I have to reboot the particular virtual machine. For that purpose only, the disk image will be taken during the termination of the virtual machine. Okay, when the virtual machine is about to terminate, the disk image will be calculated, that will be taken by the OpenNebula along with the hypervisor, and that will be moved to the known location. On the next day, if the same user start the virtual machine again in the sense, from the known location, the disk image will be deployed in the virtual machine. And the particular user can, he can access the updates, whatever the updates that he has done in the previous day, and that he can access the particular updates also. Okay, and this is how normally the virtual machine will be created, and this is how normally virtual machine will be terminated, and this is how normally virtual machine will be migrated. Okay, and in the OpenNebula and those process, the previous 5 set of process can be will be orchestrated in 3 different management areas. One is virtualizing, and second one is image management, and third one is networking. And about virtualization by interfacing with physical resources in the sense, obviously, so when we are about to start a VM, when we are about to stop a virtual machine, we need to take care of all the activities. We need to take care of all the activities that are that has been carried over under a particular virtual machine. Okay, and when coming to that image management, why do we need of image management in the sense under virtualized infrastructure? So normally the images which contains the OS and additional software that are needed by the particular virtual machine. So normally all the images are put up in an image repository, or normally all the images are put up in an image repository. Okay, and image repository which contains n number of images. Say for an example, Amazon has n number of AMI, right? Amazon is in images, right? And this image repository will contains n number of images. Okay, so like the image in the sense, like say for an example, Ubuntu environment, Fedora environment, SUSE environment, and Red Hat environment, as well as Windows Server environment, Windows 8 environment. Likewise, so whatever the environment that the user is supposed to work as a virtualized environment, and the particular cloud environment will create as an image. Particular environment will be created as an image, and those images will be put up in a repository. And based on a user request, the particular images will be taken. The particular image will be taken from that particular the image repository, and that will be put up in that will be deployed in a virtual machine. Say for an example, if the user wishes to create a Ubuntu environment in the sense, then the particular Ubuntu image will be taken from the particular particular image repository, and that will be put back, that will be deployed in the particular virtual machine. Okay, so this is how normally the image can be managed. As well as, and all the images can be taken as a clone, and that can be done also, and also we can save the images, and also we can remove the images. Okay, coming to the saving the image, what does it mean in the sense? Let's listen carefully. I have created a virtual environment as under Ubuntu. Okay, I have created one folder and 10 number of files in the sense. Okay, once I about to shut down, once I about to terminate the particular virtual machine, okay, and the last checkpoint will be created, and from the checkpoint the images will be the disk image will be created, and that images will be again put up in a known location. Okay, and on the next day, if I open the same virtual machine again, in the sense, from the known location, the particular image will be deployed again into my virtual machine. Okay, so from the moment I have left, I can resume the process. That is the purpose of saving the image. Okay, and what is the meaning of removing, in the sense, when I am removing the particular virtual machine from the particular cloud environment, obviously the data, whatever the data the particular virtual machine is holding, and everything can be removed, so that the resources can be optimized properly. Okay, so these are the process that can be done under the image management. Okay, and coming to the next one, and the networking. So whenever the VM is created, and normally virtualized address will be created. Okay, why do we need to have a IP address for virtual machine? In the sense, then only we can interact with the particular virtual machine. Then only, say for an example, if the user A wishes to create an own virtual machine, in the sense, for the virtual machine, one virtualized IP address will be assigned. Okay. So based on the IP address the particular virtual machine is holding, with the help of that only the user A can be interacted to that particular virtual machine. Okay, this is how normally the virtualized application network will be carried over for making the user to interact with that particular virtual machine. Okay, and this is about the distributed management of virtual machines, and with the help of OpenNebula, all the process can be done. Okay, and OpenNebula, it cannot alone work. Okay, it has to work along with the hypervisor, whatever the hypervisor, the type of hypervisor that the particular, what the particular cloud environment is having, and it has to, OpenNebula has to work along with the particular hypervisor to manage the virtualized infrastructure of the particular cloud computing environment. Okay, and this is about this particular topic. And if you wish, you can ping or follow me through any one of the social media platform, and we will see you on the next video. Thank you guys. Thank you once again.